Hello, Roy from Tulip here, and today I want to show you how to set up Amazon's Lookout for Vision machine learning service for defect detection in your Tulip applications. In this tutorial, I will show you how to set things up on your AWS Amazon console to provide the machine learning service and how to connect it to Tulip via connector functions. We provide an app on our library that comes prepackaged with all of the connector functions you need to get started with AWS Lookout for Vision, so you don't need to create them from scratch. Lookout for Vision is a powerful machine learning service that is able to automatically learn and to detect defects and abnormalities in images. All it needs is the right data to find these indicative visual patterns, and it will provide a predictive model within less than an hour. Between setting up Tulip and Lookout for Vision, you can get machine learning working for you on the shop floor within a couple of hours and begin saving you time and money on manual visual inspections. Before diving into Lookout for Vision and defect detection, first you need to collect data for your defect tracking application. To do that, please refer to our data collection video app and tutorial. You would also need to train a model and connect it to Tulip. The end result will be something like this. What I have set up here is a very simple inspection station with a zoom-in camera that can detect defects on this PCB. When we put the part in for visual inspection and call the model, it will respond back with a prediction whether this is a defect or not. I already collected the data, and now I want to run this detection model to find if the part is effective or not. I have a placement jig here to make sure that my part always goes under the camera in the same exact way. This is very important to get consistent results with these models. When setting up your camera, make sure it's tightly secured and that it doesn't move or drift. Okay, so I will assume that there is already a Tulip table populated with collected data and annotated for normal and failure cases. Make sure to collect at least 20 images from each class and try to avoid variations. You could try to add those variations into your data and think about the real world situation in which you would be running this inspection. If you expect a lot of variation, instead of trying to capture all of that in images, try to reduce the variations by introducing jigs to hold things in place or constraining your camera view. The key to success with computer vision is to control the environment as much as possible. From Tulip tables, you can export and download a dataset of the annotated images, which you can use right away in AWS Lookout for Vision. To download the dataset, just click the export option and use the default option. If you're using data from a different Tulip table, mark the columns that contain images and annotations. Once you get the zip file of your dataset, unzip it and note the location of the files because we would need them again very soon. To use Lookout for Vision, you need to own an AWS account. There are plenty of guides on how to do that, and the process is very simple and quick. See the notes accompanying this video for useful links. So, assuming you have created your account and logged into AWS console, navigate to CloudFormation. CloudFormation will help you set everything up in AWS automatically so you don't spend time in configurations. We provide a CloudFormation template. It's a script that has all the services you'd need to run Lookout for Vision with Tulip. It will build an API gateway with several endpoints that connect to Lambda function that call the Lookout for Vision actions. Your apps will call these API endpoints and make Lookout for Vision work inside Tulip. Just drop the template file in the upload box and start the process. Accept all default options and just let it do its thing. While it's running, you can query the status by hitting the refresh button. This process usually takes about 2 to 3 minutes. So let's give it some time. Okay, when it's done, you will see the last line of the log saying it's complete. take a look in the Outputs tab and make sure you're seeing a URL. This URL is the endpoint for Tulip to interact with your AWS setup. Make note of it, but there's no need to copy it. We will come back to this very soon. Now it's time to train our machine learning model with Lookout for Vision. Find the Lookout for Vision service on the AWS console and allow it to make a new S3 bucket for its internal purposes. We've already created a project for you to use. It's called LFV CFT, but the project does not have any models or datasets. Next, we would need to create a dataset for training from the data that you collected on Tulip. So find the S3 service on your AWS console. You can use the folder that Lookout for Vision and had created in your S3, and it usually starts with Lookout for Vision. Let's upload the Tulip exported dataset. Click Upload Folder and select the folder. Scroll all the way down and click Upload. Give it a minute to finish sending all the files. This should take no more than a minute, but it depends on how many images you have captured. Once it's done, click Close. Mark the folder and copy S3 URL. We can now switch back to Lookout for Vision. Click Create Dataset. Click Import from S3 bucket. Paste in the S3 URI you copied earlier. Mark Automatically Attach Labels and Create Dataset. This would take just a few seconds to complete. Review the dataset that was created. And make sure that Lookout for Vision gives you the thumbs up that you've collected enough data. If you don't have enough data, you can repeat the process by exporting from Tulip and uploading to S3. Let's click Train Model and get the training process going. Confirm that you want to start training. This process may take up to an hour, but it usually ends within 45 minutes. Another thing to note is that training also has some cost attached to it. Depending on the size of your data set and complexity of your model that needs to be built, a defect detection model may get complex if you are trying to find many possible defects or covering a large area. The best results are for models that are fairly specific and focused. If you're just getting started with Lookout for Vision with AWS, they do provide a 10-hour free package that can be put towards your work. Afterwards, it's roughly $3 to $4 per training hour. So let's wait for the model to finish training. Okay, once the model is trained, we can review the training results and performance metrics. There are some sample detections, and if you're not satisfied with the results, the best thing to do is to add more images and train it again. We are now ready to get back into Tulip. To make calls to our new Lookout for Vision model, we need to have created a number of connector functions. These should already be there for you when you install the library app. Locate the AWS Lookout for Vision connector. It should have a number of functions already defined on it. But first, we need to set the host name on the entire connector. So click on the box to the left and paste in the URL you received from AWS CloudFormation. Another important thing to do is to get the API key from AWS. This is how AWS makes sure that the third party calling the API functions is authorized to do so. This time, under the Resources tab, you would find API key. Click it, unhide the key, and copy it. Now, back to the connector functions. In each of the functions, update the XAPI key value of the header by pasting it in. Okay, we are all set for now. It's time to test the Lookout for Vision model. Let's run the Lookout for Vision app on the player machine, which is connected to our inspection camera. So this simple app has just a few steps. The first step is to warm up the model. One thing to remember is that even if you deploy your model, it is still cold. It won't accept calls until you turn it on. And once it's on, it consumes resources and will charge for its uptime. Try to keep your models off for most of the time to save on resources, like at the end of the shift or over the weekend. Turning the model on may take 2 to 3 minutes, so plan for that. In case you want to start running the inspections right away, you'll have to turn the model on a few minutes before. We also provide a way to see the status of the model. It will only respond to calls when it's in the hosted status. You can call the status function a number of times until you see the hosted status. Then you'll be ready to start using the model for inference. So let's give it a little bit of time to warm up and start hosting. Okay, our model is now hosted. In this step is where we actually call the model. When we click Detect Anomalies, there we capture an image from the camera and send it over to the connector function to be evaluated by the Lookout for Vision model. I will try to get a reading for both a normal and a defective part. This is a defective board. As you can see, the pin there is pushed in, and Lookout for Vision is able to tell that this is a defective part. Let's try a normal part. So for this normal part, the model is pretty confident that this is not a defect. The response will also give you a prediction whether this is a defective part or not, as well as a confidence score. If the confidence is too low to trust, you can try running the model again. In case you don't trust the prediction, or if it's flat out wrong, like in this case, we added a couple of buttons here to take this current sample and add it to the database with an annotation. If the model is consistently making mistakes, you can take the dataset from the Tulip table and use it for retraining your model with the new data samples. So I'm going to add this sample as normal. As you can see, we get an added sample to the data collection message. This way, you can continuously improve your model in terms of robustness as well as performance. Finally, we provided a way to turn the model off. All the models will keep incurring charges until they are stopped. In the off state, they will not consume any more resources or incur any charges. So we've seen an end-to-end way of going from Tulip collected data to your model on AWS Lookout for Vision and back into Tulip for running your visual inspections. Feel free to make modifications to this app once you import it and test it on your instance. For example, take the model administration steps to a different app and only keep the prediction step in this app that you're going to run on your floor. You can also add additional models by collecting more data and training them on Lookout for Vision. I hope you enjoyed this walkthrough and will try using Tulip with AWS Lookout for Vision soon. Thank you very much.